In this lesson, we're going to learn about the angle relationships that are created from a transversal and parallel lines. Here we have a diagram of parallel lines, line M and line N, and then we have line T that intersects these lines. Line T is called a transversal, and it's simply just a line that intersects two or more lines. When we have this diagram, a transversal intersecting one pair of parallel lines, we can see that we have several angles that are created. We have angle A, B, C, D, E, F, G, and H. There are 8 angles that are created. Now let's talk about the special relationships that form when this transversal intersects the parallel lines. There are 2 options for the relationship. Either 2 angles are congruent to each other or they are supplementary. So let's take a look to see what this means. Congruent is having equal measurement, and here is the notation for congruent. When we say 2 objects are congruent, we will use this notation. Supplementary angles are 2 angles whose sum is 180 degrees. So for example, angle A and angle B are supplementary, and they do create our line M. Therefore, the measurement of a line is 180 degrees. Let's just take this line here. We know that if we create a perpendicular line, we have 90 degrees on the left side and 90 degrees on the right side. Therefore, a line is 180 degrees. In our diagram, you can notice that we have angles that are on the outside or exterior of the parallel lines. So let's just kind of box this in so you can see it clearly. You do not need to do this. But on the outside of our parallel lines, we have angle A, B, E, and H. These are called exterior angles. And then the ones on the inside of the parallel lines, such as D, C, F, and G, these are interior angles. So we have exterior, the outside angles of the parallel lines. And then we have the interior, the inside angles of the parallel lines. Now let's talk about the relationship of congruent angles. So there are certain pairs of angles that have specific names based on their location. And again, like I said earlier, the relationship is either going to be that they are congruent or supplementary. So let's just focus on the angle pairs that are congruent. They have the same measurement. So 4 special names, we have vertical angles, corresponding angles, alternate interior angles, and alternate exterior angles. So let's take a look at each of these in our diagram. So like we just said, vertical angles are congruent. So if you know that a pair of angles are vertical according to their location, then you can say they're congruent. Vertical angles are opposite from one another. They share a vertex, but not a ray. So let's just review what a vertex is. So if I have a vertex, a point, and I have one ray, so that's a ray, and it has an endpoint. And then I have another ray These two rays share a point, a vertex, creating an angle. So the line portion is the ray, where it has an endpoint and it continues forever in one direction. So we have a vertex, and then we have two rays. Okay, so now let's look at our diagram. So according to this simple definition, vertical angles, they share a vertex. So here is a vertex. So let's just take a look at the top portion of our diagram. And let's switch colors right quick. Let's see if this will show. So let's just start with angle A. So angle A has, here is one of the rays, and here's the other that creates angle A. And the vertical angle to angle A is going to be C. They both will share the same vertex, but they do not share a ray. So angle A, so our notation is angle A is congruent to angle C. We can use this notation. Now let's take a look at angle B. Angle B is vertical to angle D. They equal each other. They are congruent. So let's list this. Angle B is congruent to angle D. I know that doesn't show up very well. Okay, now let's take a look at the bottom part of this diagram and list the two other pairs. And let's start with angle F. So angle F shares a vertex with angle H, but not a ray. So angle F is vertical to angle H, therefore they are congruent. So if you say F and H are congruent, you need to say so because they are vertical to each other. So you have to support your answer of why they are congruent. And these new vocabulary words, these new terms, supports your answer that they are congruent. And then our last pair, angle G and angle E, they are congruent. Angle E is congruent to angle G. These are all vertical angles and they have the same measurement. That means if angle A is 120, angle C is 120. If angle B were to be 70, angle D would also be 70, and so on. Okay, let's take a look at our next pair of angles that are congruent, and these are called corresponding angles. Corresponding angles are in the same location in respect to the transversal. So for example, angle A corresponds to angle F. They are both on the left side of our transversal and they're both on top of their parallel line. If we were to cut this part of our diagram, if we could cut that and lay it on top of this diagram, corresponding angles will line up. They will coincide. So let's erase this and let's list all of our corresponding angles. So angle A corresponds to angle F, therefore we can say they are congruent. Angle D and angle E are on the left side of the transversal and on the bottom of their parallel line. Therefore, they are congruent. Angle D is congruent to angle E. They have the same measurement. Now let's look at the right side of our transversal. We have angle B and angle G on the right side, and they are on top of their parallel line. Therefore, these angles are congruent. Angle B is congruent to angle G. And then we have angle C and angle H on the right side of the transversal and on the bottom of their parallel line. Therefore, because they are corresponding, we can conclude that they are congruent. They have the same measurement. These are called corresponding angles. Now let's take a look at alternate interior angles. They are congruent, and we've already talked about the word interior, so we're talking about the inside angles of the parallel lines. So we're talking about D, C, F, and G. And the word alternate means that they alternate among the transversal. So our first pair of alternate interior angles is going to be angle D and angle G. They alternate on the transversal. So they're on the opposite corners, so to speak, on the inside of the parallel lines. So angle D is congruent to angle G because they are alternate interior angles. They have the same measurement. Then the second pair, angle C and F, because they are alternate, they alternate. Because they are alternate interior angles, we can say they are congruent. So angle C is congruent to angle F. So we only have two pair. Now let's look at alternate exterior angles. These are going to be the angles on the outside of the parallel lines, and we're looking at alternate sides of the transversal. So we see that angle A and angle H, they alternate along the transversal. They're on the outside. Therefore, they are alternate exterior angles, and they are congruent. So it's all about the location of the angles that you are considering. And then the second pair and last pair of alternate exterior angles is angle B and angle E, and therefore they are congruent because they are alternate exterior angles. If angle B were 85 degrees, I can conclude that angle E is also 85 degrees. So those are the four pairs of relationships of congruent angles in our diagram. Now we're going to look at supplementary angle names. We only have two. We have a linear pair and we have a same side interior angles. So let's take a look at that. So a linear pair angles, they are supplementary, meaning it's two angles whose sum is 180. So these angles are adjacent, meaning they share a ray, and they form a straight line. And remember, a straight line measures 180 degrees. So we have several linear pair. So if I say angle A and angle B are a linear pair, such as here, then I know that they add up to 180 degrees, creating our line M. So I'm just going to list these. There's no notation really. I'm just going to say angle A and angle B are a linear pair. Now, A is also linear to D. So I'm going to say angle A and angle D are a linear pair. They create the transversal line. They are 180 degrees. Now let's go back to angle B. Angle B and angle C are also a linear pair. And then we have angle C and angle D, creating our line M. They are a linear pair. So angle C and angle D are a linear pair. They add up to 180. And remember, the word linear means line, and we know a line is 180. Okay, now we have another set of linear pair angles. Let's take a look at those. So we have F and G. So angle F and angle G are a linear pair. They create a line N. F and E are linear, creating the transversal line. Then we have angle G and H creating the transversal. So angle G and angle H are a linear pair. They add up to 180. And then we have angle H and E creating line N, and they are a linear pair. So we have 8 linear pairs of angles. So again, linear pair angles are supplementary. They add up to 180. Now, our last name, same side interior angles. So it pretty much tells you where these are located. They are on the same side of the transversal, and they are between the parallel lines. They are on the inside. So you can see angle D and angle F. If you were to add their measurements, they would add up to 180. So angle D and angle F are same side interior angles. Therefore, they are supplementary. And then we have angle C and angle G. They are supplementary because they are same side interior angles.